Welcome to this comprehensive course on continuous integration and continuous delivery pipeline, also known as CI/CD pipeline. In this course, we'll explore how CI/CD pipelines have revolutionized software development by automating the build, test, and deployment processes. You'll learn not just the theoretical concepts, but also hands-on implementation techniques that you can apply in your own development projects. Whether you're a developer looking to streamline your deployment process, an operations engineer wanting to automate infrastructure, or a team leader aiming to improve your delivery pipeline, this course will provide you with the knowledge and practical skills you need. Let's begin this exciting journey into the world of continuous integration and delivery. We're now entering the introduction section of our course. This section will lay the foundation for understanding CI/CD pipelines. We'll explore the core concepts, benefits, and fundamental principles that make continuous integration and delivery essential in modern software development. Pay close attention to these fundamentals, as they'll form the basis for the more advanced topics we'll cover later. Let's dive into the key components of our CI/CD pipeline course. We'll be covering 6 essential areas that form the backbone of any robust CI/CD implementation. First, we'll start with a comprehensive introduction to the CI/CD pipeline concept. This isn't just about understanding what CI/CD means, it's about grasping how it fundamentally changes the way we develop and deliver software. We'll explore real-world examples of how companies like Amazon and Netflix use CI/CD to deploy thousands of times per day. Next, we'll delve into the key principles. These aren't just theoretical concepts. They're battle-tested practices that have evolved from decades of software development experience. We'll examine how companies like Google and Facebook have implemented these principles to maintain high-quality code bases with thousands of developers. The workflow section will give you a practical understanding of how code moves from development to production. We'll look at real pipeline configurations and discuss common pitfalls to avoid. I'll share stories from my own experience about pipeline failures and successes, helping you learn from both. When we cover tools, we'll go beyond just listing features. We'll discuss how to choose the right tools for your specific needs, comparing popular options like Jenkins, Travis CI, Circle CI, and GitLab CI/CD. We'll examine case studies of organizations that switched tools and the lessons they learned. Version control is crucial, and we'll explore why Git has become the de facto standard. You'll learn advanced Git workflows used by large teams, and how to handle complex scenarios like merge conflicts and rollbacks effectively. Finally, in build automation, we'll examine how tools like Gradle and Maven can significantly improve your build process. We'll look at real build configurations and discuss optimization techniques that can save valuable build time. Remember, throughout this session, we'll be focusing on practical hands-on learning. Each concept we discuss will be accompanied by real-world examples and exercises that you can try in your own development environment. Let's explore the fundamental concept of CI/CD. CI/CD represents a modern approach to software development that has transformed how teams deliver value to their users. The automation aspect of CI/CD is particularly crucial. Think of it as creating a reliable, repeatable assembly line for your software. Every time code changes are made, the pipeline automatically kicks in, ensuring consistency and reliability. This automation eliminates the "it works on my machine" problem that has plagued development teams for years. The building process in CI/CD involves more than just compiling code. It includes creating artifacts, running static code analysis, and ensuring code quality metrics are met. For instance, many organizations use SonarQube in their pipelines to maintain code quality standards automatically. Testing in CI/CD pipelines is comprehensive. It includes unit tests, integration tests, security scans, and performance tests. Companies like Google run over 150 million tests every day through their CI/CD pipelines. this massive scale of testing would be impossible without automation. Deployment automation is perhaps the most visible benefit of CI/CD. Instead of the traditional manual deployments that often occurred during weekend maintenance windows, CI/CD enables safe, automated deployments during regular business hours. Companies like Amazon deploy code changes every 11.7 seconds on average. The key to successful CI/CD implementation is understanding that it's not just about tools, it's about creating a culture of automation and continuous improvement. As we progress through this course, you'll learn how to build this culture in your own organization. Let's examine the compelling benefits that CI/CD brings to modern software development. These aren't just theoretical advantages, they're proven benefits that organizations consistently report after implementing CI/CD pipelines. First, let's talk about faster delivery. In today's competitive market, speed is crucial. With CI/CD, teams can reduce their deployment time from weeks or days to hours or even minutes. For example, Etsy went from 2-week deployment cycles to over 50 deployments per day after implementing CI/CD. This speed doesn't just mean faster feature delivery, it also means quicker bug fixes and security patches. Early bug detection is another critical benefit. The automated testing in CI/CD pipelines catches issues before they reach production. Think of it as having a quality control checkpoint at every stage of development. A study by the DevOps Research and Assessment (DORA) team found that organizations with mature CI/CD practices spend 44% less time fixing security issues because they catch them earlier in the development cycle. Increased stability might seem counterintuitive given the faster pace of delivery, but it's a well-documented benefit of CI/CD. By automating deployment processes and including comprehensive testing, we significantly reduce the risk of human error. Facebook, for instance, maintains 99.99% uptime while deploying thousands of times per day, thanks to their robust CI/CD pipeline. The collaboration and feedback benefits are particularly interesting. CI/CD creates a shared responsibility for code quality and deployment success. Developers get immediate feedback on their changes, and operations teams have visibility into what's coming down the pipeline. This improved collaboration often leads to better code quality and faster problem resolution. As you implement CI/CD in your own organizations, you'll likely discover additional benefits specific to your context. The key is to measure your baseline metrics before implementation so you can quantify the improvements. Let's explore the foundational principles that make CI/CD pipelines effective. These principles aren't just guidelines, they're essential practices that have emerged from years of industry experience. Automation is the cornerstone of CI/CD. It's about removing manual intervention wherever possible. This goes beyond just automating builds and tests. It includes infrastructure provisioning, configuration management, and even documentation updates. For example, Netflix's automation principles allow them to recover from region-wide failures automatically, without human intervention. Continuous integration is about maintaining a single source of truth for your code. When developers integrate their changes frequently, ideally multiple times per day, integration problems become smaller and easier to resolve. Google's monorepo approach, where thousands of developers work on a single repository, is a prime example of SAY at scale. A common pitfall with CA is having long-running feature branches. Try to keep branches small and short-lived. If a branch lives longer than 1 to 2 days, it's probably too big and should be broken down into smaller pieces. Continuous delivery focuses on maintaining your code in a deployable state at all times. This requires comprehensive automated testing and quality checks. Companies like Atlassian maintain over 300,000 automated tests in their CI/CD pipeline to ensure code quality. One crucial aspect of continuous delivery is having a robust feature flagging system. This allows you to deploy code without necessarily releasing features, giving you more control over feature rollouts while maintaining rapid deployment capabilities. Continuous deployment takes automation to its logical conclusion by automatically deploying every change that passes all tests. While this might seem risky, companies like Etsy and Amazon have proved it's possible at scale with proper safeguards in place. Remember, these principles build upon each other. You need solid C before you can achieve effective CD. Start with mastering continuous integration, then gradually move toward continuous delivery and deployment as your team's capabilities mature. Let's walk through the typical workflow of a CI/CD pipeline, understanding each stage and its importance in the software delivery process. The workflow begins with code commit. This seemingly simple step is crucial. It's where developers integrate their changes into the shared repository. Best practices here include using meaningful commit messages and following conventional commit formats. Companies like Angular have shown how structured commit messages can automate changelog generation and semantic versioning. The build stage is where your code is compiled and packaged. This stage should be fast and reliable. If your builds take more than 10 minutes, they're probably too slow. Automated testing is perhaps the most critical stage. It's your safety net for catching issues before they reach production. A comprehensive testing strategy includes unit tests for individual components, integration tests for component interactions, end-to-end tests for complete user journeys, performance tests to catch performance regressions, security scans to identify vulnerabilities. The deployment stage is where your code moves to staging environments. This should be automated and identical to production deployments. Many teams use infrastructure as code tools like Terraform here to ensure environment consistency. User acceptance testing, UAT, is your last line of defense before production. While this stage often involves manual testing, you can still automate the deployment to UAT environments and the collection of feedback. Monitoring is often overlooked but is crucial for maintaining system health. Modern monitoring should include application performance monitoring, error tracking and alerting, user behavior analytics, infrastructure metrics, security monitoring. A common mistake is treating monitoring as an afterthought. Instead, monitoring should be built into your pipeline from the start. Companies like LinkedIn include automated checks for monitoring configuration in their deployment process. Let's examine this sample GitLab CI/CD configuration file and understand how it implements the workflow we just discussed. This YAML configuration defines 3 primary stages: build, test, and deploy. While this is a basic example, it illustrates the core concepts of pipeline configuration. Looking at the build stage, you'll notice it's defined as a separate job. In practice, this job might include steps like pulling dependencies, compiling code, creating artifacts, running linting checks, generating documentation. The test stage follows, which is crucial for maintaining code quality. In real-world scenarios, this stage often includes unit tests, integration tests, security scans, code coverage checks, performance tests. The deploy stage represents the final step in our pipeline. While this example shows a simple deployment, production deployments typically involve environment validation, database migrations, feature flag checks, canary deployments, health checks. One common pitfall to avoid is making your pipeline too complex too quickly. Start simple and add complexity as needed. Teams may create pipelines with 20+ stages, making them difficult to maintain and debug. Remember, this configuration file is just a starting point. As your needs grow, you might add environment-specific configurations, manual approval gates, cleanup jobs, notification webhooks, performance monitoring. Let's analyze this JUnit test example and understand how it fits into our CI/CD pipeline. While this is a simple test case, it demonstrates fundamental testing principles that apply to more complex scenarios. The test shown here is a basic unit test for a calculator's addition function. In real-world applications, your test suite would be much more comprehensive, including edge case testing, boundary value analysis, error condition handling, performance benchmarks, integration scenarios. One crucial aspect of test design is the arrange act assert pattern, which this example follows implicitly. Arrange. Set up the test conditions. Act. Execute the operation being tested. Assert. Verify the results. When implementing tests in your CI/CD pipeline, consider these best practices. 1. Keep tests focused and atomic. 2. Use meaningful test names that describe the scenario. 3. Implement proper test isolation. 4. Avoid test interdependencies. 5. Include both positive and negative test cases. A common anti-pattern to avoid is testing implementation details rather than behavior. Your tests should verify what your code does, not how it does it. This makes your tests more resilient to refactoring. Remember to include appropriate testing tools in your pipeline. Code coverage tools like Jathia, Co, mutation testing frameworks, performance testing tools, security scanning tools, API testing frameworks. The goal isn't just to have tests, it's to have meaningful tests that provide confidence in your code changes. Common build configuration mistakes to avoid. 1. Not specifying dependency versions explicitly. 2. Ignoring warning messages during builds. 3. Not managing plugin versions. 4. Keeping build logs indefinitely. 5. Not implementing proper error handling. Build automation best practices to consider. Implement proper version control for build scripts. Use build profiles for different environments. Implement proper logging and monitoring. Set up build notifications. Regular build script maintenance. When setting up build automation in your CI/CD pipeline, consider implementing build timeouts to prevent hanging builds, resource constraints to manage concurrent builds, artifact cleanup policies, build metrics collection, security scanning during builds. Remember, your build process is the foundation of your CI/CD pipeline. A reliable build process leads to reliable deployments. Let's explore this practical example of monitoring and logging in a CI/CD pipeline. This use case demonstrates how proper monitoring can make or break your deployment success. The example mentions 3 key tools: Prometheus, Grafana, and the ELK stack. Each serves a specific purpose in your monitoring strategy. Prometheus excels at collecting metrics at scale, supporting multi-dimensional data models, providing powerful querying capabilities, enabling alerting based on metrics, supporting service discovery. Grafana brings your metrics to life by creating customizable dashboards, supporting multiple data sources, enabling team collaboration, providing alerting capabilities, supporting annotations for events. The ELK stack, Elasticsearch, Logstash, Kibana, provides centralized log management, full-text search capabilities, real-time log analysis, visualization options, pattern recognition. When implementing monitoring in your CI/CD pipeline, consider defining meaningful metrics. 2. Setting up appropriate alerting thresholds. 3. Implementing log rotation policies. 4. Creating runbooks for common issues. 5. Training team members on monitoring tools. Remember to monitor not just your application but also your pipeline itself. Track metrics like pipeline execution time, success/failure rates, Resource utilization. Test coverage trends. Deployment frequency. Let's analyze this Prometheus code example and understand how it implements monitoring in a Java application. This sample demonstrates the fundamental concepts of metric collection and exposition. The code shows a counter metric implementation, but in practice you'd typically use multiple metric types. Counters for values that only increase. Gauges for values that can go up and down. Histograms for measuring distributions. Summaries for calculating percentiles. Key components in this code. 1. The counter class, from Prometheus Client Library. 2. Metric naming and labeling. 3. HTTP server setup for metric exposition. More. Metric registration. 5. Increment operation. Best practices for implementing Prometheus metrics. Use clear, consistent naming conventions. Add appropriate labels for better querying. Keep cardinality under control. Implement proper error handling. Document metric meanings. When implementing metrics in your application, start with the 4 golden signals. Latency, traffic, errors, saturation. 2. Add business-specific metrics. 3. Include pipeline metrics. 4. Monitor dependencies. 5. Track SLO/SLI metrics. Remember, effective monitoring isn't just about collecting data, it's about collecting the right data that helps you make informed decisions about your application's health and performance. Let's examine this Grafana dashboard configuration example in detail. This YAML configuration demonstrates how to set up comprehensive monitoring visualization for your CI/CD pipeline. Notice, the configuration shown here defines a Prometheus data source and creates a dashboard with specific panels. In production environments, your Grafana setup would typically include multiple data sources for different metrics, various panel types for different visualizations, alert definitions, user access controls, dashboard templating. The configuration demonstrates several key concepts. Provider configuration for Prometheus. 2. Dashboard organization. 3. Panel definition and layout. 4. Target configuration. 5. Data source integration. When implementing Grafana dashboards in your CI/CD pipeline, consider these best practices. Create role-specific dashboards: Developer View, Ops View, Business View. Implement consistent naming conventions. Use templates for reusable components. Set up proper backup and version control for dashboards. Implement appropriate refresh intervals. For effective dashboard design, start with high-level metrics. 2. Add drill-down capabilities. 3. Include relevant documentation links. 4. Set up appropriate thresholds. 5. Use consistent color coding. Remember, a well-designed dashboard should tell a story about your application's health and performance. Let's explore the various C tools available in the modern DevOps landscape. Understanding these tools is crucial for implementing effective continuous integration practices. Jenkins, as the most widely used C tool, offers several advantages. Extensive plugin ecosystem. Highly customizable pipelines. Strong community support. Integration with virtually any tool. Support for distributed builds. Travis Sive, popular in the open source community, provides simple configuration, GitHub integration, built-in support for multiple languages, container-based infrastructure, automatic deployment capabilities. Circle, Sive stands out with Docker, first approach, parallel test execution, sophisticated caching mechanisms, SSH access to build containers, orbs for reusable configurations, GitLab, CI/CD offers unique benefits such as tight integration with GitLab, built-in container registry, auto DevOps capabilities, integrated security scanning, Kubernetes integration. When choosing a CI tool, consider team expertise and learning curve. 2. Integration requirements. 3. Scaling needs. Cost considerations. 5. Support requirements. Remember, the best CI tool is the one that fits your team's workflow and requirements while supporting your automation goals. Let's analyze this GitLab CI/CD configuration example in detail. This YAML file demonstrates the core concepts of pipeline configuration while highlighting best practices for real-world implementations. The configuration defines 3 stages: build, test, and deploy. Each stage serves a specific purpose. In build stage, it compiles the application, manages dependencies, creates artifacts, performs static analysis, generates documentation. In test stage, it executes unit tests, runs integration tests, performs security scans, checks code coverage, validates quality gates. In deploy stage, it manages environment deployments, handles configuration updates, performs health checks, updates service discovery, monitors deployment status. When implementing GitLab CI/CD, consider these best practices. Use pipeline caching effectively. 2. Implement proper artifact management. 3. Define appropriate timeout values. 4. Set up proper error handling. 5. Implement deployment strategies. Advanced GitLab CI/CD features to consider. Multi-project pipelines, parent-child pipelines, dynamic environments, review apps, auto DevOps. Remember, your pipeline configuration should evolve with your application and team needs. Let's discuss version control systems and their crucial role in CI/CD pipelines. Version control, particularly Git, forms the foundation of modern software development practices. Key aspects of version control in CI/CD. Collaboration benefits include that it enables multiple developers to work simultaneously, provides conflict resolution mechanisms, supports code review processes, enables feature branching, facilitates team communication, traceability advantages such as it maintains complete change history, enables audit compliance, supports issue tracking, provides release management, enables root cause analysis. Best practices for version control in CI/CD. 1. Implement clear branching strategies. 2. Use meaningful commit messages. 3. Regular repository maintenance. 4. Proper tag management. 5. Security best practices. Remember, effective version control is about more than just storing code. It's about managing your software's evolution effectively. Let's examine these fundamental Git commands and understand their role in a CI/CD pipeline. While these commands might seem basic, mastering them is crucial for effective version control management. Let's break down each command and its significance. Clone it creates local copy of repository, establishes remote tracking, downloads all branches, sets up Git configuration, enables collaborative work, branch management, creates isolated development environments, enables feature development, supports hotfix implementation, facilitates release management, enables experimentation, staging and committing it, prepares changes for commit, creates atomic change sets, maintains code history, Enables rollback capabilities. Supports code review. Remote operations, IT. Synchronizes local and remote repositories. Enables team collaboration. Facilitates code sharing. Supports deployment processes. Maintains backup copies. Best practices for Git usage in CI/CD. 1. Regular repository synchronization. 2. Proper branch cleanup. 3. Meaningful commit messages. 4. Regular backup procedures. 5. Security best practices. Remember, effective version control is fundamental to successful CI/CD implementation. Let's explore build automation tools and their crucial role in CI/CD pipelines. These tools are essential for creating reliable, repeatable build processes that form the foundation of continuous integration. Build automation tools like Gradle and Maven provide several key benefits are: consistent build processes, dependency management, plugin extensibility, multi-module support, cross-platform compatibility. When implementing build automation, consider 1. Build performance optimization. 2. Proper dependency management. 3. Version control integration. 4. Test automation integration. 5. Artifact management. Remember, effective build automation is crucial for maintaining consistent and reliable software delivery processes. Let's delve deeper into the key aspects of build automation tools in CI/CD pipelines. Understanding these aspects is crucial for implementing effective build processes. Simplified build configuration including declarative syntax, reusable components, environment-specific settings, cross-platform support, plugin management, dependency management consisting of transitive dependency resolution, version conflict resolution, repository management, scope management, security scanning, build lifecycle with defined phases, custom task creation, parallel execution, error handling, reporting capabilities, plugin ecosystem that has extended functionality, community support, custom plugin development, integration capabilities, maintenance considerations, best practices for build automation. 1. Regular dependency updates. 2. Build script version control. 3. Performance monitoring. 4. Security scanning. 5. Documentation maintenance. Remember, effective build automation is about creating reliable, repeatable processes that support your CI/CD pipeline. Let's analyze this Maven POM configuration example in detail. This XML configuration demonstrates essential concepts for managing Java project builds effectively. The POM file structure includes project coordinates, group id, artifact id, version, dependencies section, build configuration, plugin management, resource declarations. Key aspects to consider. 1. Dependency management, which includes version specification, scope definition, exclusion handling, repository configuration, conflict resolution. 2. Plugin configuration, which includes compiler settings, test execution, resource handling, code analysis, documentation generation, best practices for Maven configuration, use dependency management. 2. Implement proper versioning. 3. Configure appropriate plugins. 4. Manage build profiles. 5. Document configurations. Remember, a well-structured POM file is crucial for reliable build processes in your CI/CD pipeline. Let's examine this Gradle build configuration example and understand how it implements build automation in a CI/CD pipeline. Gradle's Groovy-based DSL provides powerful capabilities for build automation. The configuration demonstrates plugin application, repository configuration, dependency declaration, task configuration, test setup. Key features of Gradle: 1. Incremental builds. 2. Build cache. 3. Parallel execution. 4. Custom task types. 5. Dependencies optimization. Best practices for Gradle builds. 1. Use the Gradle wrapper. 2. Implement proper caching. 3. Configure parallel execution. 4. Manage dependencies effectively. 5. Optimize task ordering. Remember, effective Gradle configuration can significantly improve your build process efficiency. Let's analyze these common build tool commands and understand their role in CI/CD pipelines. These commands form the foundation of automated build processes. Maven commands. Mvn clean package. It cleans previous builds. Compiles source code. Runs tests. Creates deployable artifact. Mvn test. It compiles test classes. Executes unit tests. Generates test reports. Validates code quality. Gradle commands. Gradle build. It compiles source code. Processes resources. Runs tests. Generates documentation. Creates distribution. Gradle test. It executes test suites. Generates reports. Validates coverage. Checks quality gates. Best practices for build commands include: use appropriate flags. 2. Implement proper logging. 3. Configure timeouts. 4. Handle errors effectively. 5. Monitor performance. Remember, mastering these build commands is crucial for maintaining effective CI/CD pipelines. Welcome to our deep dive into YAML. In this section, we'll explore a critical component of modern DevOps practices, YAML, which stands for YAML Ain't Markup Language. This recursive acronym hints at YAML's philosophy. It's not just another markup language, but rather a human-friendly data serialization standard that's become the backbone of many DevOps tools and configurations. Let's examine the key value pair syntax shown in our slide. The example demonstrates how YAML uses a simple colon to separate keys from their values. This straightforward approach makes it easy to read and maintain configuration files. The colon must be followed by a space for proper YAML syntax. The slide also shows us how lists are created in YAML. Each hyphen represents a new item in the list, and the consistent indentation helps maintain the structure. This format is particularly useful when defining multiple related items, such as configuration options or deployment steps. Comments in YAML, as shown in our example, begin with the pound symbol. These comments are invaluable for documenting your configuration files, explaining complex settings, or noting why certain choices were made. The parser ignores everything after the pound symbol on that line, making it safe to add detailed explanations without affecting functionality. Looking at the scalar section of our slide, we see several fundamental data types in YAML. The string example shows how text can be enclosed in quotation marks, which is particularly useful when your string contains special characters. The number example demonstrates that YAML automatically recognizes numeric values, no special syntax needed for integers. The Boolean example shows how YAML accepts true as a Boolean value. It's worth noting that YAML is quite flexible with Boolean representations, though in our example we're using the straightforward true format. The null value demonstrates how YAML handles undefined or empty values. The sequence example in our slide shows a simple list of fruits. Notice how each fruit is on its own line, preceded by a hyphen and a space. This vertical formatting makes it easy to add or remove items while maintaining readability. The mapping example in our slide demonstrates how YAML handles complex data structures. We see a person object containing multiple properties. The indentation clearly shows that name, age, and city are all attributes of the person. This hierarchical structure is fundamental to YAML's ability to represent complex data relationships. The nested structure shows how YAML can handle multiple levels of data. Each level is indented further than its parent, creating a clear visual hierarchy. This format is particularly valuable in configuration files, where you need to represent relationships between different components or settings. Our slide shows two crucial features for handling text in YAML. First, we see the multi-line string syntax using the pipe character vertical bar. In the example, the pipe indicates that line breaks should be preserved exactly as written. This is particularly useful when dealing with configuration files where formatting matters, such as script contents or log templates. The greater than symbol, greater than demonstrates YAML's folded style, where each line break is converted to a space. This is ideal for long text that doesn't require specific formatting, making it more readable in the configuration file while being processed as a single flowing paragraph. Looking at our slide's examples of inline collections, we see how YAML can represent data more compactly when needed. The fruits example shows an inline list using square brackets, with elements separated by commas. This format is particularly useful when you have a simple list that doesn't benefit from the vertical hyphen format. The person example demonstrates an inline mapping using curly braces. This compact format is valuable when you want to keep related data together on a single line, making it easier to read and maintain certain types of configurations. Notice how the key value pairs are still separated by commas, providing a clear structure even in this condensed format. We're now moving into the practical application of what we've learned. The assignment will focus on creating a CI/CD pipeline using GitLab CI/CD. You'll be applying the YAML concepts we've just covered to create real pipeline configurations. Looking at the requirements in our slides, you'll need a GitLab account and a sample application. The goal is to create a functional pipeline that handles building, testing, and deploying your application automatically. Let's look at the first set of configuration tasks outlined in our slide. For the GitLab repository configuration, you'll be setting up a fresh repository or utilizing an existing one. The crucial step here is cloning this repository to your local development environment, which creates a working copy where you'll implement your CI/CD configuration. The slide emphasizes creating the GitLab CI.yml file, which is the cornerstone of your pipeline configuration. This YAML file needs to be placed in the root directory of your repository, as GitLab specifically looks for it in this location. Looking at the requirements, you'll define multiple stages: building, testing, and deploying. Each stage serves a specific purpose in your pipeline, creating a comprehensive automated workflow. The task specifies that for deployment, you can simply copy the artifact to a location. This simplification allows you to focus on understanding the pipeline structure without getting caught up in complex deployment scenarios. It's a practical approach that still demonstrates the key concepts of continuous deployment. Moving on to the build and test stages detailed in our slide. The build stage configuration requires you to set up compilation of your application code. This is where you'll specify how your application should be built, ensuring that it compiles successfully and generates the necessary artifacts for later stages. Looking at the test stage requirements, you'll need to configure automated testing that runs against your built application. The slide emphasizes using a suitable testing framework. This means selecting one that's appropriate for your application's programming language and requirements. The test job must be configured to provide useful test reports, which means including proper test output formatting and error reporting. The slide specifically mentions that the test job should run without failures. This highlights the importance of writing reliable tests and ensuring your pipeline can handle test execution properly. Remember, in a CI/CD pipeline, failing tests should prevent progression to later stages, protecting your deployment environment from untested code. For the deployment stage shown in our slide, you'll need to configure the job to deploy your application to a target environment. The slide mentions choosing a suitable deployment strategy, whether manual or automatic. This choice depends on your specific needs: automatic deployment for faster delivery, or manual deployment for more controlled releases. The pipeline visualization requirement is particularly interesting. The slide specifies configuring the pipeline to generate a visual representation of stages and job statuses. GitLab's Pipeline Editor, mentioned specifically, provides this visualization capability, helping you understand the flow and status of your pipeline at a glance. Finally, the slide emphasizes the importance of committing and pushing your changes to the GitLab repository. This step is crucial as it triggers your pipeline, allowing you to see it in action and verify that all stages work as intended. The push operation makes your pipeline configuration available to your team and starts the automated CI/CD process. Your final deliverables, as outlined in the slides, include your GitLab repository with the complete GitLab c.wiml configuration. You'll need to document any challenges you encountered and their solutions. Think about how this pipeline could be implemented in your work environment and potential future enhancements. This hands-on experience will give you practical skills in pipeline configuration using YAML. 2. CI/CD process automation. 3. GitLab CI/CD platform usage. 4. Best practices in DevOps workflows. Today we've covered YAML fundamentals and their practical application in CI/CD pipelines. We explored YAML's syntax, data types, and advanced features, all essential for modern DevOps practices. Through the assignment, you'll gain hands-on experience creating a real CI/CD pipeline using GitLab CI/CD. The skills you've learned today form the foundation of automated software delivery pipelines. Whether you're working on small projects or enterprise-level applications, understanding YAML and CI/CD principles will help you create more efficient, reliable development workflows. Remember, the key to success in DevOps is continuous learning and improvement. Take what you've learned today and experiment with different pipeline configurations and automation strategies in your own projects.